Right now,
That's amazing.
that becomes green.
Holy crap. That is scary.
All right, we are live now.
We're live.
Dude.
Hopefully they're saying something.
You should see the UI. I mean, just visualize the creepiness of the tracking of people.
I don't know if I want to see that.
Yes.
Okay. Yes, we are being live streamed tonight. I don't know if you guys realize that, but we're on YouTube, which is just as good as TV nowadays. So we're on TV. That's pretty cool. All right. So welcome tonight. Tonight we're going to be talking about OTP, which is great. Thank you, Christian. Christian's going to be our speaker. But before we get into the topic of the night, we have a couple of traditions that we do. First, before we do too much, I want to give a great thanks to Viget. And Viget is the space that you're in now. They provided the pizza, the beer that some of us drinking, and the drinks. So thank you, Viget, for sponsoring tonight. You've been a really good sponsor, actually. Yeah. All right. So some of the traditions that we have are quizzing, I guess. And the prize is some nice little nifty socks. So if you were here last time, you would know that we did this. We've done this 3 or 4 times now. But also, I picked up new socks since the last time you were here. So now we have taco trucks. So those are pretty nice.
On every corner.
Ooh, okay. And then we have astronauts. This is actually a shout out to All Things Open. By the way, you should go to All Things Open. It's coming up soon. We also have some Super Mario themed socks, right? That's pretty cool. These are all adult socks. Some of them say men, but they're lying. And then we have some comic book ones. Yeah. All right. So now that I have gotten you all very interested in these socks, these are prizes that you can win by answering the quiz correctly. So here's the quiz. So we have 2 functions here in the enum module. We got dedupe and unique. And if you had a variable there called enum, containing that list of numbers 1, 2, 2, 3, and 2, these 2 functions do something to them. Are they doing the same thing? What do you guys think? I'm hearing a no. We got anything else? What do you think? I mean, it's like this is a Boolean check here, right? Is this equal to, you got 50% of being right here. No. All right. Yeah, you're good. You're right. And I heard Kate first. So Kate gets to come up here and choose the socks of her choice.
You'll have to go.
So cool. Yay, Kate. All right. So yeah, dedupe is pretty interesting. I didn't know that there was a difference until I did this quiz. I've used unique a lot. Cool. Got the astronaut ones. So yeah, dedupe is going to remove duplicates in consecutive order. So that's the difference. So we had 1, 2, 2, 2 being the consecutive order there, and it deduped those. It didn't remove the 2 on the end of the list, so that's the difference. Unique will look at the whole thing. Dedupe will just look at consecutive values. So dedupe is more efficient if you know that your list is going to be in that order. So that's nice. So today I learned dedupe is a little bit faster, but unique is the entire list.
What if you did enum.sort and then dedupe? Would that be faster than unique?
Whoa, no idea.
Oh, not faster.
And unique would be faster?
That might be how you is implemented.
Yeah, I was thinking
Since they're linked list, I would suspect that's how it's implemented.
they definitely wouldn't, because that would be too loose correct.
Well, lazy.
Yeah, if it was a screen, that would be, yeah.
Good question.
Because dedupe can be implemented with a reduce operation. In other words, you just check the next item, and then just back to the list. So it's a single version of it.
Nice. You almost deserve another sock, but we'll see. All right. Congrats, Kate. All right. So last time we talked about rumors in the community, in the Triangle Elixir community, Elixir community. We don't have rumors here because we're all legit. But the Elixir community has some rumors. So last time we talked about field punning. If you don't know what field punning is, that's this whole JavaScript trick where maybe, well, that's where I learned it anyway, was in JavaScript, where you can kind of shorthand way destructure and assign a variable based on the key that it's in, right? So here's a little example. If I have a map here with the key of hello, value of dog, you can, in a function, either in the, in a function, you can destructure and assign hello, which matches the key, and then that also assigns the value there. So we talked about that last time. Here to proudly announce that rumor is false. That is not going to happen. For explicitness, right? We won, right? Okay. So, but if you are interested in that, there's actually 2 libraries that are pretty cool and help implement this style if you're interested. The first one, I hate how it cut off, but anyway, the first one is actually something that you like. You use this library in your module, and then it actually looks like that, right? Which is pretty cool. The other one, short maps by What You Hide, who is on the Elixir core team, I think. Short maps is like adding a sigil, so you can kind of make a hash looking or a map looking thing, but then like tack on like S, I think, at the end, and it'll do something really similar, which might be a little bit more.
He removed that library a week ago.
He did?
Yeah,
He says he regretted it.
Oh, well, he regretted it, so screw that. Okay. Okay. Next, if you don't know, a couple weeks ago we had a Elixir Conf. It was in Bellevue, Washington. It was a long way. Sorry, Pierre, you weren't there. It was really good. Several of us were there. So just to update everyone else, what happened? We talked about several things. First, we had a great talk by Zach, and we had another great talk by Michael Stalker, who's not here tonight. But he was, both of them gave great talks at ElixirConf. Zach talked about breaking down the user monolith, which he gave here a couple months ago. So good talk, great job, buddy. Cool. And then Michael also gave a great talk on picking fields to choosing fields to property test. So how to know what to property test on your stuff, which is pretty cool.
He also got a shout out on Elixir Outlaws, that podcast.
He did? Nice. Cool. Smooth it on up. Okay. So other big topics of that night was Scenic UI, Phoenix Live View, and /Texas. They both kind of do the same thing. And Nerves Hub. Scenic UI is like Elixir's entry into native UI development. So on desktops right now is where it's focused, but it also works on Nerves, which is pretty cool. So you can burn that stuff into a Raspberry Pi, and then if it's connected to a display, it'll work there too. So that's pretty cool. Like without Linux, right? It's without Linux, which is pretty cool. Which you can do that. Yeah, that's pretty awesome. Nerves, so Scenic is that. It's OpenGL driven and pretty cool. It's like believes in OTP, pretty cool. It's like on stage he crashed a button and then you didn't even see it disappear. But like crashing a button and then not the app still living is pretty cool. Another big one was Nerves Hub. So we talked about Nerves a little bit. Nerves is a deployment tool for getting your Elixir software onto embedded hardware. Primarily, it's things like the Raspberry Pi. Not as small as the Arduino, but a little bit bigger, like the Raspberry Pi. It handles burning onto the SD card, and it handles the Linux subsystem there, and that's what Nerves does. Nerves Hub is like an over-the-internet update system for that, which is really cool. So like you could literally on your terminal say mix Nerves Hub, publish your version, and only deploy it to my test group of devices. And your test group is assigned to Nerves Hub and the UI on the web, and it's these 3 devices sitting right here, and that's it. And so over the net, those Raspberry Pis receive the request to update. They receive their new firmware, they burn, they restart, and then they reconnect. And that's what Nerves Hub does. So that's pretty cool. And then yes, what?
Is that a paid thing or is it free?
Free, I think. Okay. Yeah, which seems hard to believe now.
Yeah, they have a website. It's still not working pretty perfect.
So, and it's pretty cool. And it's open source, which is also pretty cool. Yeah. Yeah, pretty nice. Okay, and then we ended on Phoenix Live View. Now there's also a session on Texas, which is a library. But the whole concept here is that think of it as a partial on your web page, and this partial is this little section on your page. And if a change happens over the WebSocket, your server will push an update to that partial. So think of like single page applications, so things like React, what that effect has. Think of that kind of effect, but being pushed from the server to the client over WebSockets. So that doesn't sound very sexy, but just look up the demo. It's pretty cool. Phoenix Live View. That is not published, but Texas is, and Drab. Drab is also in this space, but that's been published for a while, and it's pretty cool. So again, that's all Elixir driven. All these users are connected, and you can push updates to their browsers via WebSockets, and the browser will update that little partial and not do a full refresh. Right? So it's pretty freaking cool. All right. So before I take any more time of Christian's, we're going to hand it over to him, and we're going to learn a little bit about OTP today, which is a great hidden feature, not so hidden maybe, of Elixir. So, Christian?
All right, awesome. Thanks for coming out. Let's see here. All right. So, as you may know, since 2006, our computers the processor speeds have tapered off somewhat, and you start to see more and more cores coming into computers with quad-core, 6-core, 8-core, and the like coming more to our machines. Obviously, you guys know this because you work in Elixir. The performance is pretty fantastic. But the idea here is this demands that we write applications that can scale across multiple cores and multiple machines. There are languages, for example, Ruby has the global interpreter lock and other sorts of things that cause you have to do other tricks to actually make it concurrent. So OTP is the concurrency model of Elixir, and I've worked in quite a few languages, and I can say it's my favorite concurrency model. It's pretty exciting. So the other thing is, because Elixir is a functional language, you get immutability, which makes your memory management, your garbage collection under the hood much easier to manage. So OTP stands for Open Telecom Platform, not one-time pad or anything else. So I'm going to start with a couple of quotes by some folks in the Elixir and ERLANG community to sort of get us started on what this is all about. So of course, Joe Armstrong, the primary creator of ERLANG, he says OTP is an application operating system and a set of libraries and procedures used for building large-scale, fault-tolerant distributed applications. That's a lot of buzzwords. So in other words, this is a whole framework. It's not just a particular library that you use in your application, but instead it's principles and the actual libraries together. In fact, as we'll see in just a minute, there's sort of 3 separate components to it. Also, another quote that I found helpful is by Cesarini and Vanosky, and they say, OTP is a domain-independent set of frameworks, principles, and patterns that guide and support the structure, design, implementation, and deployment of ERLANG systems. In other words, all this stuff, whether you're aware of it or not, you're taking advantage of OTP in your applications, if, for example, you're using Phoenix. And we'll talk about that a little bit more later. So, as I mentioned, there's 3 components of OTP, as described in one of the resources that I'll mention at the end. So there's sort of ERLANG, which is running, it's Beam as well, which is the virtual machine running all your code. It includes, doing your schedulers across however many cores you have in your computer, scheduling these processes, and taking full advantage of that, or even communicating across nodes or computers to make your application fault-tolerant and even more distributed than before. There's also tools and libraries. So if you've ever used some of the ones from ERLANG, Amnesia, iNet, what are some other ones? Was that?
ETS.
Yep, ETS. Yep, and we'll talk about that too. So these are tools and libraries available. But what we're going to focus on tonight are the system design principles, and this is how to actually use OTP and understand how it works from the ground up, as much as you can in a 45-minute talk. So let's start by discussing the basic unit of processing concurrently, which is the ERLANG process. So if you've worked in other languages, you may be familiar with processes and threads. And so an Erlang process is not to be equated with an OS process. Neither is it to be equated technically with threads. So because you have the virtual machine running your processes, it can manage even making them lighter weight than a thread. Now, the closest equivalent would be a green thread, which I think there's some other languages, and not remembering the list of them that have somewhat similar functionality. But the idea is starting up a single Erlang process for maybe like the first 250,000 is only going to take a single microsecond. This is very, very fast. And their memory footprint is going to be much smaller than even a thread or a process, an OS process. So as I mentioned, they're lightweight and they are scheduled by the virtual machine and the schedulers that appear across all the cores of the computer you're using. So they use a mailbox system. So in this sense, if you ever heard the quote from Joe Armstrong, he says that Erlang is the most object-oriented programming language ever, which may be a little bit of an overstatement, but the idea is if you're modeling if you think of objects as processes, they really just send messages to each other. So take that however you will, but that's sort of the idea. So you send messages, and these are copied in essence to the programmer, and they're not going to share memory like you would with threads in a typical operating system thread. Additionally, they operate via a client-server relationship. So originally Erlang was written for phone systems, and so it's very common where you'd have multiple requests coming in and having these processes having to communicate with them. So if you ever watch one of the introduction videos that Jose does, he often talks about how the processes, or how that sort of thinking for phone systems really maps quite well to the internet and APIs and stuff like that, where you have all these clients and servers. So these can be on the same machine, they can be on different machines, and it's really not much overhead from the programming perspective of making that happen. So to examine this from the ground up, we're going to start with just building a super simple module for writing an Erlang process using just the native function spawn link. So the basic process architecture here, unlike most object-oriented languages, or just most languages in general, Erlang has a philosophy of a lot of times designing your applications around these processes. So instead of maybe if you're working in Java or iOS where you use like Grand Central Dispatch where you dispatch something off, it runs and you come back and you're done with that, OTP processes are usually designed to run much longer term. And you can even have your application structured around that, which that also allows you to do some cool things with actually designing what they call the happy path in your program, so that if things go awry and your button crashes, your application still survives that. So the idea here is that you start it, initialize it with some state, and then you have a single loop. So this is not working with GenServers or any fancy things. This is just spawn link. And then, of course, you can terminate at the end when you're actually finished. So to do this, I'm going to go through an example of using a URL shortening service. And you have to suspend some disbelief because it's not very fancy. It's just key value pairs. But the idea here, so this was sort of a test you're writing. You have shortening URL, you tell it to shorten, and then you can retrieve that URL afterwards. So I'm shortening apple.com to APL, and then I can receive that back out and get the URL here with the assert receive. And likewise, if you find a URL that doesn't exist, it has an error. So let's jump into this real quick. So here I have the test on the right. Is that big enough for you guys? Need it bigger?
Yeah.
Is that better? All right, cool. So here we can define shortener basic. And the convention here is I'll use a start link. So we're using the default or the native function spawn link, and we'll tell it what module and function to use for this. And then we'll pass it a list of arguments for the initial state. So this is sort of our start period. So obviously if we run the tests, it still breaks because we're sending messages. Actually, it needs to have this function defined. So the basic way of receiving from this mailbox is via a receive block. And these are pattern matched on what's actually going to be received. So in other words, if I do this, the message, and then I run the tests again, you'll see here, right, told it you initialize it with state here. So our initial state here is going to be this empty map. And if I look up here, you'll see these are the messages that are being sent in. So we can pattern match on those to do whatever we want. Okay, so here we could say shorten process ID, shorten representation in the URL that we're actually going to receive. So here we can send a message back, and send is that native function that's going to send a message to communicate to the process. And we'll send it back a message. Let's see. It looks like we sent OK. Let's see the idea. Now this next part, so receive will block your current process. So if we loop here and call ourselves, we now have a recursive function, of course, and then that receive block will wait for another message that pattern matches. Now, if you're not familiar with this, this is called tail call optimization in order to make this happen properly. The idea is, in some languages that don't have this optimization, if you recursively call a function enough times, you'll have Stack Overflow because it adds another frame to the stack. By making this last call to our function and recursively calling it, it doesn't add another frame. So that's a feature called tail call optimization. So if we see here, it runs again, and we gotta do this last one here. So this is the URL. And if I scroll up here, so we still need to handle this message here. This is the shortened representation, and then we can send back to this process. And let's see, what is the keyword to pull it? Here, fetch. So we fetch out of this state our shortened representation, and then we can loop with the existing state. And actually here, sorry, this should update like that. So it's the key is short and the value is URL. And there we are. So in other words, in the first case, we're just sending a message back. In the second case, we're just sending a message back. We don't care about updating our state. In the first case, we actually want to assign that to our key value store. Any questions about that? Okay, cool. And we're not going to cover the termination stuff for right now. So jumping back to here. So there are some pros. This is very simple, easy to use. We have now spawned a process, had that communicate, and everything is dandy. Now, unfortunately, this doesn't handle edge cases. If you have two processes that make a synchronous call to each other, you get deadlocks, you can erase conditions, all the stuff. The other thing, this is actually really important to understand to understand the value of GenServers, which we'll cover in just a minute. So if your message does not pattern match, it sits in your mailbox, and it can indefinitely fill up your mailbox and have memory issues. That's why at the end there, you could have like a final statement that just matches on nothing and doesn't do anything. GenServers will blow up if you send a message that it doesn't understand for that very purpose. The other thing is that there's some other features that we'll get to, just sort of mention, not actually talk about too much. But you notice in the example, I have to pass around this process ID. I can't refer to it by some module name or things like that. And we'll get to how that you can make that super easy to use. If you ever use Ecto, you don't have to worry about process IDs and stuff. You just say, okay, go do this. It actually has this whole structure of pooling and workers and all the stuff that you don't have to see at all. So let's talk about OTP behaviors. Remember, we're talking about the system design principles of OTP. So these are called generic behaviors. And we have the classic GenServer, and these are all abstractions on this spawn link that we just saw. There's also GenStage, which if you ever use ReactiveX or RxJS, these sort of things, we have producers and consumers of state. They're really nice, but I won't go into that too much. Finite state machines. Elixir doesn't have a particular module for this natively, but in ERLANG you do have that. GenEvent, which apparently was removed from Elixir, and so you have to go back to ERLANG for that. And then GenTCP, which in a live demo at the end, I'll show that off. So you can actually create a server using just the native functions. There's also supervisors, and technically there's a third component, which are OTP applications. But the basic process we'll be focusing on are the actual GenServers. These are the processes that will be doing work for you. The supervisors will then handle if your worker dies, what happens, when should they restart, what state do they need, all this other stuff. So the GenServer has this client-server abstraction, and it works via a callback module. So in other words, you call GenServer and say, hey, I'm a module, and I'm going to implement this sort of behavior. I will receive messages according to our established convention. So the GenServer functions, which will sort of cover that, are things like start link, cast, and call. And I have a quick diagram here that is, I think, somewhat helpful. So the idea is this is the actual GenServer module, and this is our example callback module. So we have this sort of start link. We tell GenServer, okay, go ahead and start your process and tell me when you've done that. And you get these callbacks of setting up your process, and then you can receive messages both synchronously and asynchronously, which follow the conventions of a call versus a cast. And then, of course, you can have stop, or if things blow up, there's other callbacks that you can receive for that. So let's upgrade our spawn link system to use a GenServer. So you'll notice here we don't have all these fancy tuples floating around of these like 4, 5, 6 elements to actually communicate our messages. Instead, this is starting to look a little bit more like just regular Elixir code, but we just make sure we have as the process identifier for this example. So same exact sort of thing, we're just using function calls to make it happen. So let's take a look at how this is actually implemented. So if I walk over here to this is going to be server test. And we will run that. Okay. And then this. Okay, so here's the test on the right. The idea here is to write shortener.server. Okay, so same sort of convention. We're going to start with a start link call. And this, by convention, matches GenServer's start call name, so that you can sort of signal to people outside, hey, this probably does something more than nothing, other than just writing functions and having return values. So here, this is just convention. But the idea here is we call GenServer, and we're going to have a start link. So we're saying now that our current module is going to be the callback module that you care about. Then we give it the initial state, and there are other options you can pass to it. And this is where you would have, you could refer to it as an alias or pass other options to GenServer. So this is going to give us callbacks. So we have init, as you saw before, and this is where this callback is before your process actually is spawned. If you have any state to set up, and will actually terminate your process if it doesn't finish within 5 seconds, I think is what the cutoff is. But the idea here, so if we wanted to write our functions, so we have shorten, process identifier, the URL, and the shorten representation. So we would say GenServer.call this PID, and then here is where we would start to use those tuples yet again to send the message. But by doing this, it's all encapsulated in the module rather than having to know exactly what those are outside of this. So shorten. Let me see if I can remember what this is. So this should be, I have my little cheat sheet over here. So shorten URL. And so if we were to run this test, so we get a lot of errors. But you'll see here, it says handle call is not defined. So the callback that we need to implement here is handle call. And then we pattern match on this result, short URL. Now this is where the GenServer gives us some advantages. So we can know what the process is coming in if we wanted to communicate back, and our return value will specify a communication back to that other process. So like it says, it's an abstraction. And then we have the state automatically passed in here. So it's a nice little upgrade to make things a little bit nicer. So here, I went ahead and did a little bit of extra things here. So if we have, so if we don't already have the key in our map, we'll go ahead and add it. So we reply, okay, and then our third item will be updated state. And then if we receive okay, then we will say and we don't care about the state update there. So now we should see, okay, 3 tests, 2 failures. So we now have a passing test. Hooray. All right. So the other thing here is going to be URL, and this is where we just pass in the shortened representation. And that should be it. And then we'll go ahead and define this instead of running the test again. Don't care about the from there. And here we can just say to reply. And this convention of reply is stuff that GenServer is expecting you to return and will do what it has agreed to do. This is fetch state shortened version. And then we loop with our existing state. And if all went well, we have some passing tests. So any questions about this thus far? I'll give you a minute to sort of look at it real quick.
So the start, like handle call, you have to define those methods because GenServer expects them. But the start link, you're just kind of defining because that's signaling to the outside caller that like this is probably using.
Exactly. Yep. So if you couldn't hear that, Starlink is a convention that I wrote that name, and the rest of these are actually callbacks and then will blow up if you don't define those. All right, let's jump back here. So this is nice. We now handle edge cases, which you didn't even see it, just whoosh, it's there. GenServer does it for you. And we have the additional features of GenServer. It's a little bit more of a sending message abstraction, so it's a little nicer to work with. We do still have some cons. So this is a single point of failure. This is a single process. And it would, of course, be a bottleneck if you have all these clients making calls to you as a single process. Now, if you're working in a Phoenix application, this is super important to understand. So Phoenix is written on top of Cowboy, which is written in ERLANG. And the idea is it spawns a process for each connection and each request. So think about it this way. If you're writing in your controller action some code, you're actually distributed across all these processes of requests that are coming in. If you write a single GenServer and make calls to it, you're going to have a bottleneck, almost guaranteed. So you have to remember that. Don't go out there and just immediately write everything in GenServers. If you're using Phoenix, you have to know this. That's why, for example, Ecto uses pooling of workers, and it'll restart them and all this other stuff. So Elixir also has these other abstractions because we like to make things easier to write than Erlangers, and a little bit friendlier community. I like to think, at least. So tasks and agents sort of do the 2 separate things that a GenServer does together. So tasks are for a single long-running function. So as I mentioned, this is sort of closer to traditional languages in terms of how they use separate processes. You spawn this function, it goes and does some work, and it comes back, good to go. This is totally cool to use anytime in your Phoenix controller actions because it's just spawning a new process and it comes back. These can also be supervised. We won't talk about a whole lot there, but if you need your workers to restart or different behaviors, you can customize that. And then you can block your current process whenever you feel like it. So you can do other work on your current process.
Are those garbage code?
Yeah, all of this is managed for you.
After they finish it, they are garbage code.
Everything's handled for you. Yep. Okay, and then agents are the other part of it. So while a GenServer does both state management and these long-running type functions, an agent is devoted to state. So you'll see a lot of anonymous function declarations of getting state and updating it and returning it, and that's all it does. That's sort of the focus there. So storing and retrieving state is not directly supervised. So let me just take a couple examples here. So task async, this is the tasks. You do some long-running work, and then when you say task await, that's what blocks your current process. You can also do a link process. You can put it in a supervisor. This is the old declaration syntax, but you can use them pretty easily without having to implement your own module. So agents, like I said, they're sort of the opposite. So if we have a set of items we're trying to manage, you have a get, and you can have an update, and you can have a get and update. So very simply revolving around state. So these are abstractions that you have to make a choice of when to use them and when they're going to boost your application the most. So that was a little aside for some of the abstractions in Elixir. If you go to ERLANG, I'm sorry, they're not there. So let's refactor this into a worker. And I'm not going to write this all out because I don't want to type that much. So the idea for this URL shortener, we want to make this distributed, right? Because we need to handle all of these URLs. It's going to be really computationally expensive. So we spawn a dedicated worker per client, and we want to have them reference the same data without conflict. And we don't really care about a database at this point. One of the things that I sort of learned from reading a lot of the ERLANG literature is they don't spring for databases quite as often as Elixir developers. I think that part of that is because of the community background. A lot of guys are coming from Ruby, and that's pretty much standard if you work in Rails. Like if you have a Rails app that doesn't have a database, that's an oddity. Like it's just unusual. So we will use ets, which someone mentioned before, to do this. And I'll just go over the code briefly here. So this would be the test. Not doing any edge case tests here, but the idea is ets is able to handle a bunch of requests from different processes and works as an in-memory store. So ets itself stands for ERLANG term storage. So here, all I have to do, the only state that I care about for these workers is a reference to this table. And then I can have them have one of them, or insert something into the table, and both of them have that result coming out. So let's check this out.
What's ETS for folks?
Et stands for ERLANG term storage. Yep.
What does it do?
So it allows you to basically have an in-memory table. You can think of it almost as an in-memory.
It's like Redis.
Yeah, and it actually do more than Redis in terms of the feature set. Yeah, so you can have like a bag set, you can have a set, you can have, but
It's like Redis. But then understand this Elixir structure is.
Gotcha.
yep,
Yeah, you can query with pattern matching.
yes,
Pretty slick.
yep. Some of the querying is a little bit crazy though.
Yeah.
Okay, so here's the worker, and let me open up this test. And here, I'm not going to run these tests. You're going to have to just trust me on this one. So you'll see the same conventions here, so the same exact stuff, and we have a init, same stuff. Now here, the only difference is my state is automatically just my table reference. And then I can do the updates, exactly the same sort of feature set, except we're using ets to do that. Any questions about that? I'll give you a minute to look at it.
Does insert do anything with duplicate keys or values?
It depends on the type that you've declared that the ets table is. So yes or no, depending on how you set it up.
What would it take?
Well, yeah. Yep. So bag set, word set. I don't remember the other ones. I think for this one, I'm using a set and I declare it as public, which I'm looking over here. So public means it can be called from multiple processes instead of the one that you just spawned it from. So you could make it private. All right, let's move on. So let's jump to a demo. So I'm hoping you guys have your computers. Some of you, we'll see. How many people have used Telnet? The excitement is raising, I can see. Okay.
The first time I tell it something was exciting.
It was shady?
No.
Oh, exciting. Okay, just exciting.
And then I sent an anonymous email.
Very,
That was shady.
very exciting. Okay, gotta have both. Okay, so if you do have a computer, I'm going to demonstrate this. So this is the observer tool, which I find to be extremely exciting, and I will explain why in a moment. And I will go ahead and exit out of that. So here's the URL I want you guys to go to. So if you will, it's a little bit smaller.
You have your own login banner, that's great.
I did not write it myself. Don't worry. So telnet, 0.tcp, ngrok.io.
Did you have to install Telnet? It doesn't come with the system, apparently.
Really?
I was going
Not
with
sure.
No, it's not a Mac. Linux,
yeah.
I thought it was just installed by default.
Not anymore.
That's weird because I just got it on my Mac.
Is NC there? Yeah, just try it.
What is
Yeah,
it?
NC is there. Yes. So if you do telnet, we should be able to see some connections coming in. I'll let you guys go ahead and type that in, because it's not as exciting of a demo if I don't have a couple people. So I will very patiently sit and wait up here.
Brew install telnet first.
Okay, that's right. So while we're doing that, all right, I'll let you guys see this one.
Updating homebrew first.
Okay. Sorry, the stream is interfering with your speed. So this is cool. So I can see the OTP applications that are currently running. Oh, did you paste it in there for me? Someone did? Someone did? Okay, so notice here I have a worker. So somebody already submitted some text here. Maybe not. Oh, this is coming off of this. So this was a new connection that was just spawned. So I have a connection process and a request process, I think. And this worker is actually going to be what we just saw. So if you just hit anything, it'll spawn a new process there. As you can see, I've labeled it by the IP address here. And you can follow the wonderful help guide. And no, it does not have autocomplete, if you're wondering. So we can say shorten like that, and we can then retrieve it out. And there we go. And you guys should be able to do that same URL, APL, and it should be referencing the same state. I'm still not getting anybody in there.
I got it. I'm in.
Yep, I'm in there.
I shortened.
So how is this not updating?
Restart it? No. Refresh the
It should
UI.
be live. It doesn't refresh that often. So
Well, but these are spawning here. Oh no, the IP addresses are all matching because it's ngrok tunneling it.
Oh, whoops.
I didn't even think about that.
It's just one connection.
Because before when I did this demo, I did like a device network, but since we're streaming, I can't do that. So you guys got to trust me in that part. Now, if you type /die, you'll see one of these identifiers here change. Okay, so this one just changed. So in other words, it's restarting the worker. Which, as I mentioned, we're not talking about supervisors tonight, but that's sort of the idea. So we can also see here, which, as I mentioned, this is the observer tool. So you just say :observer.start with parentheses, so you don't get a warning. And you can see what was shortened here without having any extra stuff. Obviously, I wasn't very clear in the documentation because somebody flipped it. I did the same thing. All right.
How do you quit?
How do you quit? You have to use the escape character. That works too. Yes. Kill the worker. Just toss it. And this should update. There we go. So that's pretty cool. All right, let me jump back to the slides here. So here are some resources I found helpful. I read a significant portion of the Designing for Scalability with ERLANG and OTP. It was very helpful. It is all ERLANG, so you're going to have to use the capitalizing variable names and using dots and semicolons and commas and all that stuff. The other one that's really good is, what is it called? The Little Guide to OTP. It's Benjamin, I don't remember his last name. There you go.
that's great.
Yep. Elixir in Action is really helpful if you just want a quick introduction to it, and that's all in Elixir. So syntax-wise, you don't have that overhead, but it's still a lot of fun to write ERLANG, so you want to pass up the opportunity. So here's the repository, and you guys can take a look at that. And now I have time for questions. Any questions?
You know
Did all the
when-
processes die? No. Go ahead.
When would you want to supervise something versus not?
So in the case of like a task that you're just spawning off other, long-running process, if you don't care if the work completes or not or errors, then it doesn't matter.
Don't supervise.
Yeah, but if you're starting a structure application around it, you're going to want to supervise it. Yeah.
So my question is, this is very uninformed because I know nothing about like scaling OTP systems. But like let's say you have a GenServer that you create a GenServer that's long running, so it holds state. Let's say a shopping cart or something instead of using Redis, right? Then you sort of introduce like statefulness to that one server, so you can't just have a load balancer that like randomly routes, each like request to a random anonymous app server that will handle it, right? I mean, how do you even go about doing that? Would you like create? Do you have set up a separate server where you'd be running like ETS or your GenServers or?
You could certainly design it that way. I've not done this in practice, but I would generally, if you don't, I mean, generally speaking, you don't have to have a load balancer in front. You can obviously for serving static assets, that'll still be faster, and routing to multiple machines. But I think the traditional ERLANG answer would be design your application such that it spawns on multiple computers. So your application is written to distribute across those. So for example, the Phoenix presence feature, I'm not sure if you're familiar with that, but the idea is that you can see if users are online across multiple nodes. It's doing that communication for you. And I think a lot of the...
So, okay, could you make, like, so if you don't have load balancer, I guess all requests would go to one, like, central computer that would then, I guess, distribute the request to others? Is that?
You need a distributed system there, and that's like a hard topic. There's like many ways. You have Nemesia, and ERLANG or Elixir where you can, it's like ETS, but you can distribute it among multiple nodes. And it's kind of easy, but also if one node crashes, it doesn't have to network partition. So the distributed systems are not easy.
Yeah. So in other words, you could still have a load balancer and have your applications communicate if they need to.
Yeah.
You can also do it with DNS stuff. I mean, there's a bunch of ways, but the idea is to be aware of your concurrency across machines if you're going to start to write your own OTP behaviors.
Yeah, or maybe you create the nodes in a way where this node is handling, like, I don't know, million users, and the other node is handling another million. So you can have ETS there, and like one node doesn't care about the other states.
Yeah, segment by organization or grouping. Yeah. All great ideas. Yep.
So choosing what is the case.
There's also a great talk at ElixirConf that is related to this, but their problem was that the apps were in containers that were ephemeral. So there's some libraries out there that can abstract some of this away and try to like make your OTP applications also distributed and communicate with each other and know how to shut down and start up and reinstitute state, rehydrate, and all that stuff. So there's several libraries out there. I think Horde is one of them.
What's the
Swarm is another.
What's the talk called?
It's like
something with Docker.
Can Docker and Elixir be friends?
Yeah, Daniel Azuma from, probably did not say that right, but from Google. I can also
Friends
say
or foes, Docker and OTP.
that's it. That's it. Friends or foes.
Okay, so for those on the stream, friends or foes on combining or having OTP applications communicate between Docker containers.
Right.
Correct? Okay.
Right. Yeah, because inside the Docker container is all that state that doesn't sometimes escape, right?
Right.
So how do you recover from that?
Yeah, I mean, just remembering, I think, how ERLANG, its original uses, and we didn't have all of these types of special things, and so they were built to be able to handle that all on their own.
You don't really need a container for ERLANG or Elixir.
Right.
You can use it, but it's like just reinventing the world again.
Yes, I mean, you get orchestration and integration of existing tools for Docker, but yeah, it makes it hard.
With stateful sets, that's good because you can still bring the node back and it has the same state. So it's Kubernetes, it's very friendly with Elixir. Right?
All right. Thank you all very much. Safari. Yeah, cool.
Thank you.
It's so painful. They modify everything on their way and it doesn't work.
Cool. Thanks, man. That was great. It's always good to know about that kind of stuff. Like OTP, it's like coming from the Rails world. You don't know that kind of stuff, right? So this is awesome reminder of what one of the many things that makes Elixir really awesome. Inheriting from ERLANG, of course. So before we head out, got a couple housekeeping. Yeah, I'm gonna make y'all clean up. housekeeping is jobs. So always good to know what's going on in the community. If there's if you work anywhere or know of any places that are hiring, specifically Elixir, but anything's really good. If you know of any Elixir positions, man, that'd be great. So I'll just go across the room. If anyone knows anything about positions, let me know. Raise your hand, say something. Going once, going twice. Okay, there's no jobs in Durham. That's great.
I'm looking for a job that pays lots of money but doesn't have very high requirements on me.
Or expectations. Yeah, that's
You
great.
guys know already.
Yeah.
Those high paying standards.
Yeah.
Yeah. Low standards, high pay. That'd be great. Right. Okay, so remotes. Yeah. No accountability. That'd be great. So great. So you came tonight, which is great. There's other meetups that we do and participate in. One of them is Modern Web. So Modern Web is having a talk. They just had one earlier this week about UX, which is great. But next month, right, the day before Halloween, actually, October 30th, it's going to be Modern Web again. And there's going to be several topics. One on D3, one on scaling your application based with design standard. I got that all mangled, but Brandon Mathis will be talking about how to scale your design with your app, I think, as well. And also, we're going to be talking about, I am specifically talking about how why Elixir is so enjoyable to work in. So be sure to come out then on Modern Web. That's Modern Web, but we also have some plans for this meetup. I believe on the books we have some topics like getting Blinky with Raspberry Pi flavored Elixir. That is an unofficial title. I have no idea what the real title will be. But the idea is that Elixir, one of the domains that Elixir plays in is hardware and Raspberry Pi. We talked about nerves, right? It's that whole thing. And so we haven't talked about that recently. So it'd be really good to figure out what Elixir can help with there. But we also have a lot of other great ideas like, for folks tonight was a great introduction to OTP. If you're interested in learning a little bit more about Elixir and you don't know about it already, we can talk about some basic features of Elixir, like the syntax, pattern matching, that kind of stuff, not field punning, because we're not into that. Also, like once you've written some of your own helpers, how to extract that into libraries. Phoenix is a big deal. It's one of the big areas, domains that Elixir is really well known for. Web applications, for example, and WebSockets, and how to talk to end users like that. Probably more immediately, this is not in any order, by the way, is lightning talks. So if you learn something really, really cool and want to share with the rest of the community about that, a lightning talk is probably a good place to start. So it's not a full talk. It's like 5 minutes, 10 minutes of something that you learned. It doesn't have to be anything special. It could be just like, man, like agents. I freaking love agents, and I want to show you what I learned about that and how I applied that in my problem space. So that'd be a really good lightning talk. And Ecto is also a good topic. So that's it. Modern Web, we talked about that, and that's my flyer. Cool. Thank you guys for coming. And pizza's in the back. Be sure to pick up some of that. I don't want anyone left hungry. And thanks, Christian, for setting up all this streaming stuff. That was really pretty neato. And thanks for letting me use your computer. Feel free to hang out and chat, but we're done, so feel free to.